Hello, I would like to spend time with you today talking about how to sketch graphs from derivatives. I think that this process is really cool, and I hope that you like it too. So I would like to start by saying that I think that there are four basic pieces of functions. I think that functions can look like that in places. Functions can look like that in places. Functions can look like that in places, and functions can look like that. And if you're allowed to draw things like this, maybe not all the way, but just some segment of these curves, then you can draw any curve you want. Like, I can be like up, 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 right? Like, there's a function, and it's built out of these four basic pieces. So what I want to do with you is talk about how do I know when I'm doing this, when I'm putting the function together in terms of the pieces, how do I know where to put these interval lines to break up my functions? Okay, so how do I know where these are? And then how do I know what piece to put in these various places? Okay, so let's first talk about the four basic pieces of a function. And this is for smooth functions. If you have a non-smooth function, like if your curve is like a fractal or something like that, then these pieces won't do, but that's okay. Okay. So we're really sketching graphs of differentiable functions, and they had to be differentiable because we're doing it from derivatives, and if your function isn't differentiable, then it doesn't have derivatives. Okay. So I would like you to note that, we'll see here. Well, so this one right here is increasing. This one right here is increasing. This one right here is decreasing. And this one right here is decreasing. I want to also draw the concavity arrows on this. So that one's concave down, concave down, concave up, concave up. So I think that we should flip either these ones or these ones. And I'm going to choose to flip these ones because that way, like, increasing will be above increasing. And then, like, the down's going to be below the up. So I've got down, down, up, up. This seems good. So I want increasing, decreasing. I'm going to flip these two on the bottom right here. And the reason is that then I'm going to be able to like draw a nice little like matrix kind of thing on this. Okay, so I need to flip these two. So this one was like that. So I have that piece, which means then that I have that piece. So let's draw increasing, and this is decreasing. I promise it's decreasing. Maybe it doesn't look like that because of my speedy or hasty drawing. Okay, so it's decreasing. And let's draw the concavity arrows. I have concave down, concave down. Okay. So recall, this is a super important thing that I want you to take away from Calc 1. If you take away like 10 things from Calculus 1, I want you to take away that increasing functions have that f prime is bigger than 0 on that interval. Decreasing functions, f prime is less than 0 on that interval. Slightly less important, but also tremendously important to take away from this class is the concavity of a function is given by its second derivative. Okay, so concave up means that f double prime is bigger than 0, and concave down means that f double prime is less than 0. What this goes to show is that the four basic pieces that I'm going to use to construct graphs of differentiable functions, all I need to know is the first and second derivative SIGN signs. So the signs of the first and second derivatives on these intervals right here. Okay. Now you should note that f prime will go from positive to negative or negative to positive across critical points. So here's a critical observation. F prime changes sign only at critical points. Okay? And F double prime changes sign only across inflection points. Okay. So recall critical points are places where f prime equals 0 or f prime does not exist. And inflection points are going to be where f double prime equals 0 or f double prime does not exist. So what we're going to do is we're going to do the two steps, right? So we're going to find where is f prime, where are the critical points, and where are the possible inflection points. And we're going to label those. And it's possible that they're coincident, and it's possible that they're not. So let's draw our concavity arrows. Okay, so there are concavity arrows. And then I'm going to put the sign of f double prime below. So I'm going to find these sets of points. They're going to lead to these things right here. And then I'm going to test points in the middle in order to find the SIGN sign. So in order to construct this graph, f double prime had to be negative, positive, negative, negative, positive, negative, positive, and then negative again. This is more complicated than a function that we would give you in this class, but a computer would happily do this. I also want to know the SIGN sign of f single prime. Okay, so this function is increasing, 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 decreasing, 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 decreasing. So would have negative, 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 negative. So there's kind of a process that is not illustrated in this video because I wanted to show you how the 4 building blocks can be used to construct any differentiable function. And those 4 building blocks come from whether it's increasing or decreasing. That's one value. It's either increasing or decreasing. Could be constant, but probably not. Increasing or decreasing, or concave up, concave down. So the combination of those 2 possible values across those 2 properties gives the 4 pieces. So you need to figure out when sketching a graph, is it increasing or decreasing, right? Is the sign of f prime positive or negative? Is it concave up or concave down? What's the sign of f double prime? That these and then these points right here, all of these points are either crit points or possible inflection points. Okay, so kind of like it's going to be like first you're going to find the critical points and inflection points, and then 2, I think you should figure out what the SIGN sign is by sampling, like plug in convenient values to f prime and f double prime in each of these intervals. And all you have to do is know what the SIGN sign is. It doesn't matter what the actual value is, just the SIGN sign because we're just sketching. And then 3, it's like grab the appropriate thing, grab the appropriate one of the 4 building blocks and put that building block in place. And that's the general process. Again, not illustrated with a concrete function in this example, but just put together in terms of this. So thank you very much. Good luck with your sketching of your functions, and be well.